Okay, so let's do the part 4. So let me put it here. Sorry, I had to change of computer somehow. Tigridity, yeah, Tigridity was giving me a hard time now on my other computer, but here should. Oh, sorry guys. Let me skip here. And then I'm gonna make it bigger. Uh, wow, sorry, I don't know what's happening. Sorry, this is a Mac. Let me put it here bigger, like this then. Okay, so part 4. For part 4, uh, what we know is that we can have, if we use the superposition principle, let me see how this works, if this works fine. So instead of infinity, if I have a finite sum until n, okay, then a finite sum like this by superposition principle will satisfies the wave equation and conditions 1, 2, and 3. Yeah, 1, 2, and 3. But then I need to satisfy. I need to get satisfied uh, also equations conditions 4 and 5. So 1, 2, 3 is satisfied, but 4 and 5 are not satisfied. So that's what I'm going to try to work. Okay. So this is the solution. This is my candidate of the solution. Okay. So I'm going to assume that if I'm going to assume that all the sum of the partial solutions that I found. Okay. So I'm going to try to see what happens if I consider the sum of all the solutions, because finite solution, the sum of the final solutions is a solution. So my solution will look like that, infinite sum. And for the case t equals 0, display me okay, sorry. So forget about this part, is over here too. So if t equals 0, let's study condition 4. ux0 equals f of x. So we're gonna do condition 4. So that one is this one, okay? So if I do condition 4, so I plug in here at t equals 0, so this will be 1, and this will be 0. So my ux0 will be d to the n sine of n pi xl, as this one. Therefore, if f of x satisfies the sine Fourier series, then uxt will be a solution of 1, 2, 3, and 4. Okay? If f of x can be written as a Fourier sine series. Okay? Good. What about the condition 5? So I need to take care of condition 5. Condition 5 says, oh, I think I wrote it here. Condition 5 says that derivative with respect to time of ux0 has to be equals to g of x. Some g of x. So that's what we're doing. We're trying to figure out what kind of g of x we need. So we find the derivative with respect to time of u, that is the candidate. The uxt is the whole thing here. So we are going to interchange the derivative with respect to time with the infinite sum. And for this part, that's what I insisted so much in the convergence. Okay, so we saw that in order to change derivative with respect to sum, we need some kind of uniform convergence. Okay, or any other the other theorems that I mentioned. Okay, so assuming so far we need to make sure this is true, but so far we're gonna assume we can do this. Okay, we need a formula. So if we interchange the sum with the derivative with respect to time, then I will find the derivative, partial derivative with respect of time of all these guys. So this guy doesn't have time, so this guy will be a constant, so it stays constant. and the derivative with respect to time of these guys is, this is constant, but the derivative of cosine is sine, nc pi t over L, times the derivative of the inside. The derivative of the inside is nc pi L, okay? Plus e to the n times the derivative of sine is cosine, nc pi t over L times the derivative of the inside, nc pi L. So now when I plug in at 0, this is gone, and this is give me 1. So my condition on g of x is g of x must be of the form nc pi over L times e to the n times sine of n pi x over L. So it's almost a Fourier sine series. So this is a Fourier sine series. However, this will change totally my equation, my function. Okay. So this is not really a sine Fourier series. However, it could be that all the incidents are 0, so g of x could be 0. Okay, so for the whole real line, if g of x is 0, we will have, like, if this is the whole real line, we will have a traveling wave. So it will be something like a wave traveling in this direction. A wave. Oh, sorry, I don't know. This is making something weird. Let's see it works. So it will be a traveling wave going in that direction. Sorry, let me see. This is not very friendly. Okay. And now let's see if it works. Okay. So it will be a traveling wave going in that direction. Like water wave. Okay. That's on the whole real line. And for this case, g of x will just go here, pick on L, and go back, as I showed you in the beginning. Okay. So finally, uxt is a solution. Uxt is a solution. Uxt. So the solution of the wave equation 1, 2, 3, 4, and 5 will be of this form, as long f of x can be written as sine Fourier series and g of x can be written as this infinite sum. Okay, so we have solved the wave equation right here, 1, 2, 3, 4, 5, and it could be, depending on the initial data f of x and g of x, it could be modeled something like this, or so it's like a traveling wave, or a vibrating string of a guitar. Okay, so we have solved heat equation, we have solved wave equation, and coming week we will be solving the Laplace equation.